Good morning to all. In this video lecture, we are going to discuss about electromagnetic waves. Contents: Introduction, Maxwell's field equation, plane wave, conclusion. Aim: to study the theoretical basis of electromagnetic waves, to study Maxwell's field equations. Introduction: Electromagnetic waves, which consist of both electric as well as magnetic field components, first predicted in the year 1864 by Maxwell, then later experimentally confirmed by Hertz in 1887, which results the change in electric field and magnetic field would continuously generate each other and propagate and carry energy with them. Nature of electromagnetic waves. Electromagnetic waves are transverse waves. The transverse wave are those in which direction of disturbance or displacement in the medium is perpendicular to that of propagation of the wave. The particles of the medium are moving in a direction perpendicular to the direction of propagation of the wave. An electromagnetic wave that traveling along z-axis, then its electric field oscillating parallel to x-axis, its magnetic field oscillating parallel to y-axis. Maxwell's field equations. First one, Gauss law for electrostatics. Del dot D is equal to 0, that is divergence of electric displacement is 0 in free space, or del dot E, which is equal to 0 in free space. And second one, Gauss law for magnetostatics. Divergence of B is always 0 because there is no magnetic monopole. Third Maxwell's equation, that is Faraday equation. The curl of electric field, which is equal to minus of dou P by dou T. And fourth Maxwell's equation in free space, that is Ampere's modified equation, curl B, which is equal to mu naught epsilon naught dou E by dou T. Wave equation in terms of electric field intensity E. We know the Maxwell's third equation, curl E is equal to minus dou P by dou T. Now taking curl of third Maxwell's equation, we get curl of curl E is equal to minus dou by dou T into curl B. Apply the standard vector identity, curl of curl E, which is equal to gradient of divergence of E minus of del square E. So the above equation becomes gradient of divergence of E minus del square E, which is equal to minus of dou by dou T of curl B, which is equation 1. We know that the first Maxwell's equation in free space, divergence of E is equal to 0. So the above equation becomes minus of del square E is equal to minus of del square E is equal to minus mu naught epsilon naught dou by dou T of dou E by dou T, because curl B, we know that for fourth Maxwell equation, curl B is equal to mu naught epsilon naught dou E by dou T. So the Maxwell's equation in terms of E becomes del square E, which is equal to mu naught epsilon naught dou square E by dou T square, where C is equal to 1 by root of mu naught epsilon naught. Hence, the wave equation becomes del square E is equal to 1 by C square dou square E by dou T square. So this is a required wave equation in terms of electric field intensity E for free space. Next, wave equation in terms of magnetic field induction B. Take the curl of fourth Maxwell's equation, curl of curl B, which is equal to mu naught epsilon naught dou by dou T of curl E. Once again, apply the standard vector identity formula. Curl of curl B is equal to gradient of divergence of B minus of del square B. Then the equation becomes gradient of divergence of B minus of del square B, which is equal to mu naught epsilon naught dou by dou T of curl E. Substitute equation B and C, that is Gauss law for magnetostatics and Faraday equation in the above equation 3, we get minus of del square B, which is equal to mu naught epsilon naught dou by dou T of minus of dou P by dou T. So del square B is equal to mu naught epsilon naught dou square B by dou T square, where C 1 by root of mu naught epsilon naught. Hence wave equation becomes del square B, which is equal to 1 by C square dou square B by dou T square. The above equation 4 is the required wave equation in terms of magnetic field induction B. Conclusion: electromagnetic waves are transverse in nature. The electromagnetic waves is a second order partial differential equation that describes the propagation of electromagnetic wave. The speed of electromagnetic wave is 1 by root of mu naught epsilon naught. Thank you.